Hey, everybody. Thank you so much for joining us here today. Really excited to talk about all things connectivity and how that relates to zero trust. I want to just introduce your speakers here. Hi, my name is Lauren Buckman. I'm the Director of Product Marketing. I'm here with my incredible partner in crime. Jordan, you want to say hello to everybody?
Hello, everyone. Jordan Gleisner here, the Director of Product out of Wilmington, North Carolina.
So we've got both coasts represented in North America. Great. So thank you again for joining us. I want to share a little bit about our agenda today. We're going to leave plenty of time for Q&A at the end of the session. And just as a reminder, we're recording this session and it will be available in the next couple of days if you want to go back and watch or share with one of your teammates. Sound good? All right, let's get into it. We're here to talk about connectivity, but first, let's ask the question, what is zero trust? So zero trust is not actually something that you buy as a product. It's a framework, and that framework has several requirements. And on this next slide, we're just going to point out these are the requirements that are in place for you to meet the zero trust framework. And today we're not going to focus on all of the requirements here. We're really going to be focusing on that first requirement, which is what you have to do for your connectivity. And if nobody minds, I'm going to do a shameless plug that we will be holding future sessions where we deep dive into some of the other requirements. So if those are of interest to you or your teammates, stay tuned and we'll have that content coming in the future. But today it's really like you've got to have connectivity to each endpoint across your organization. You need to be able to do microsegmentation. You've got to have least privilege access. You've got to be able to verify these conditions on a regular basis. You have to be able to do monitoring and analysis. And then because we're all in dynamic environments at work, you have to have adaptive policies so that you're continuing to adjust and change as conditions are changing within your organization. So these are the requirements of the zero trust framework. And today, what we're here to talk about is what connectivity means as part of it. You cannot have zero trust if your connectivity and policies are not reaching every one of your resources across your organization. And here's a list of what those can look like. We all know about your infrastructure as a service, your SaaS, your PaaS. You might have your internal applications, some of your self-hosted resources. And then also when you get into the IT world, being able to bring your own device to work. You've got laptops, you've got mobile devices. This is a dynamic business environment. We're traveling for work. We need to be able to have connectivity wherever we go. And then you've also got things like field IT where it gets really interesting. That can be like we've got multiple offices, we've got a branch, like we're dealing with retail over here, or maybe you're even getting into the IoT space. So for all of this to work together and to have zero trust, you got to have connectivity to each and every one of these resources. But the thing is, that's not enough. You can't just have connectivity. You have to have connectivity that all of these machines and endpoints have to be accessible by policy enforcement points. And it can't just be connectivity only works and these methods only work if you've got uptime. Has to be reliable, and we have to be able to reach our critical infrastructure. So that's a non-negotiable. Performance has to be non-disruptive to business tasks. And then finally, given the way that we're all working today, your connection mechanisms need to be able to provide a consistent end user experience. So no matter where you're dialing in from, if you're working from a conference, if you're on site with a customer, you got to be able to connect to your critical business paths and your critical business infrastructure and do so in a way that feels frictionless. Making this work is not easy. And I think our next slide has a little bit of a preview of how this has traditionally been managed. So with the diversity of connection points and networking needs that we have, oftentimes people have ended up with sort of a smattering or a matrix of VPN hubs and gateways, where depending on what type of endpoint people are using, you may need a different type of connection point, so on and so forth. And these are good for maintaining security and keeping things under, keeping people out. But it also means that there's many more points of failure and it becomes really complex to manage. And so when that complexity or when people run into friction or performance issues, We want to think that everybody would just be patient and wait for the connection to form or wait until they can get back to the office to make it work. But let's also be honest, that doesn't always happen. And so just want to bring up a kind of typical workaround pattern. Um, so let's assume that your average developer isn't exactly champing at the bit to set up their own Bastion host, and they're struggling for whatever reason to deal with the current VPN setup, but they've got work that they need to get done. Maybe they need to set up an AWS instance and they want to SSH into it. Let's say they're working from home that day. So a typical workaround method that you see mapped out here would be to bypass the VPN and assign a set IP to provide that access. Maybe that's their home IP. And they're able to get in and they haven't broadcast that and it's just their home IP. So they think this isn't that big of a deal. And sometimes this gets called security through. But when that happens, that means we don't have an encrypted tunnel. It's done over the public internet. And now there's not just a blind spot for the IT teams, but there's also a vulnerability here that someone can come along and just spoof the IP address, gain access to some of your most critical systems, and cause some pretty big headaches. The challenge for this modern connectivity and for making zero trust work is really has to be working really quickly. It has to be easy to maintain, and it needs to work for people every single time because they're going to find a way to get their stuff done. So that's what's going on in the broader world. And it sounds maybe frustrating or not very fun. I'm going to pass the mic to Jordan, and we're going to talk about the approach that we're taking to this connectivity and enablement of zero trust at Tailscale. Jordan.
Perfect. Thank you, Lauren. And yet, as she mentioned, we're going to try to go into like how you can enable some of this with Tailscale. But I think ultimately what the idea here is really we want to reduce all that complexity you see with traditional solutions, right? To make it so people don't have to do those workarounds like you were seeing before. And when we talk about the future, what could be the nirvana here is no longer having that central point of failure with that central VPN server, but more moving to more of a mesh solution where you have lower latency because we're driving peer-to-peer connections. And here we talk about Tailscale again, the idea of the nirvana of having these peer-to-peer connections without having to have that control plane in the middle. It gives you lower latency, obviously, when you don't have to go through that hot point, but also higher throughput as well, and also increased security without having that man in the middle. Again, when you're looking at something like this, you still have that dot where you see in the center, but it no longer acts as a central control, like a choke point. It acts as a control plane for you to push your rules out to the rest of the network and make sure they're enforced at that node layer. And if you think about the internet today and where it really should be, we talk about the idea you would have identity and encryption by default, and you'd really be able to just connect anywhere to anywhere, right? No matter the device type or OS. And inside Tailscale, we call this the new internet. And that really is our key driver of where we want to go, right? But our customers today are already enabling that idea inside of their corporations, right? Using our new identity-based mesh networking, which is built on top of WireGuard, if you're not familiar. Again, this forms the foundations to give us these end-to-end encrypted tunnels. And on top of that, we add Tailscale identity, which allows you to control through network policies exact access to who can receive what and who can talk to who. And so here what we see is Amelie, you'll excuse me as my French is not that great, logging in through her identity provider, whether that's GitHub or Google or Okta, going through Tailscale and that being attached to every network request that happens. Again, you as platform administrators or network security administrators have secured platform rules here allowing saying exactly which machines or which groups of machines Amelie can connect to. And here you see the green dots as we move around. Again, this is a completely programmable network allowing you to again, when we talk about being able to react to what's happening out there, there is nothing better than automation to get that done. Moving forward a little bit, talk about a lot of the kind of the common ways of connecting things and getting devices into this nirvana of the Tailscale or Tailnet. First, we have the ideal way, which is the way we obviously want everyone to run, which is you put a Tailscale client directly on a device and you get all the benefits of bringing it up into the network. So you get immediate peer-to-peer connections. You obviously get ingress and egress across other nodes inside the network. And again, really the easiest way to get started, you can go and click this on your MacBook or a cloud instance via Cloud Init and have this up and running. Also, if you're a home lab, we had a couple earlier, you can actually connect Apple TV and others and bring all these devices by running native clients. Now you can not always do that, whether we're talking about we have a huge scale of, an entire fleet of VMs or office devices that we're trying to bring on the tailnet in mass, or maybe we have devices where we don't have a native tailnet client, such as printers or others that we see large businesses doing. And here we do have the idea of a subnet router, which should be familiar to many, where an external client can connect through the subnet router and then get IP-based access into these pieces underneath the network, essentially merging that subnet into the tailnet. Now, we also, of course, are not always inside of our network. We also want to deal with the internet and things external to us. And we talk about secure access to the public internet. We really talk about exit nodes in our terminology. And here, what you do is you run another instance of the Tailscale client running on a specific device or devices, and you route all your internet or public internet traffic through that. This really, again, allows you to have that one central point where you can direct traffic out. You can apply guardrails there with DLP or DNS filtering if you'd like. We also have the ability to, again, run these in different regions. If you're looking at doing specific use cases like testing applications, specific geographic regions, or maybe you have certain places where you only want customers coming in from out. Again, allowing you control of your company's access to the public internet. We also have the idea of app connectors. So there's the general public internet, your YouTube and your Facebook, but then you have things like GitHub or Salesforce, these really secure SaaS apps where you want to direct users through a secure connection to those. And what we allow you to do is lock down that connection using an app connector. And in combination with rules on the other side, you actually restrict access, making sure users on your side can only get to GitHub or your sensitive information inside of Salesforce if they're actually logged onto the tailnet and your ACLs allow that identity to get through to that resource. Now, those are a couple of the common ways we see. So downloading to device or subnet router. We also have the idea of split tunneling here, which if you're not familiar, pretty much allows you to run two sets of DNS at once. You have your internal resources and those external resources like we were talking about either on the public internet or other servers off of the tailnet. This again allows you to have that really low latency on all those pieces that are inside the network, but allowing you still to have frictionless access to everything else you need to. We're also seeing more and more users bring in Tailscale into their Kubernetes networking, whether we're talking about human to machine use cases and allowing admins to get in, as we'll talk about in a second, or actually doing machine to machine connections, connecting clusters across regions or across cloud providers, and doing that all on top of the Tailscale primitives. And finally, we do have a new idea that's been out for a while, but not something we've pushed so much publicly. It's a Go programming language named TSNet that we'll go into a little bit, allowing you to program the network access directly into your programs. Excuse me for 1 second as I have one sip of water. As we mentioned, we're seeing more and more customers move in or take Tailscale into their Kubernetes environments. I'm sure as you're all aware, there's not too many companies today that don't have some kind of footprint inside of Kubernetes. And what people are seeing more and more with our solution is the idea of having one frictionless workflow across those legacy workloads that are on VMs, either in VMware or inside the cloud, and these more modern container-based workloads like Kubernetes. And here we have 4 major use cases. The one is really about securing access to that API server, making sure whether you're talking about just general admins connecting and spinning up workloads or CI/CD pipelines that are interacting with this cluster API, making sure that you have to be connected to the Tailscale. And again, your identity is confirmed before you're able to access these features. We also have the idea of private cluster ingress and egress that we'll talk about a little bit more. And again, that ability to connect clusters in different regions or different locales or different clouds even, connecting them and allowing for seamless connectivity between them. Should mention again, when we talk about zero trust and all these pieces, it all does really come down to that idea that the identity is based into the network. You are zero trust by default when setting up on Tailscale. And here we're seeing an example here of a developer or an admin on Kubernetes needing to have that secure access to kubectl to do their job day to day. And so what we have here is the Tailscale operator has been spun up inside of that Kubernetes cluster. We have a lot of different features that you can install via this operator, but here we're talking about the API server proxy that sits in between your users and that API server, first validating their identity from Tailscale and then matching that up to a Kubernetes identity, as we'll see here in a second. Again, providing that secure private access for the team and machines. It brings your IDP groups from GitHub or Okta or others into this and allows you to act and access rules off of those, and really removes the need for jump boxes or bastions, which are a lot of pain for the operating team, obviously, to spin those up and keep them running. but also really not the best developer experience either. Here we're giving people one hop directly in to get their job done as they want to do. And we talk about that frictionless Kubernetes authentication. Excuse this giant jumble of YAML, but I think it's important just to see how easy it is to configure. Here we've already had the operator installed and we're trying to spin up that API server proxy. I think really the key bit here to look at is this red box, which is this idea of Tailscale auth. What this does is this comes with the operator, and again, it delegates the authentication of the user to this engine instead of the standard Kubernetes engine. And so what's going to happen is your requests are going to come in over the tailnet with that identity, whether that's a user or machine embedded into the request. This proxy is going to look at that and then translate it down into a Kubernetes identity. If this is a user as part of a group, it's going to match that to that Kubernetes user or group inside of Kubernetes that's already set up. Or if it's a machine, it's going to take the tags and match those into groups in Kubernetes. Again, matching those two worlds together in a seamless Tailscale kind of way. The other kind of pieces you're seeing here is really us connecting this back into a specific tailnet. But really the key part is that last piece, that frictionless Kubernetes authentication. The other big piece we see is the idea of exposing workloads or services that are working inside of your Kubernetes service or clusters and exposing those either to users or other services or machines that are on your tailnet. And we have the idea of private cluster ingress here. So again, we have that operator running inside of your cluster. Once you've annotated a service with a specific kind of keywords that match up to Tailscale and say what you want to name this object on top of the tailnet, excuse me, the operator recognizes that and spins up an ingress proxy automatically on your behalf for you. Once that is available, the service is then broadcast onto the tailnet and advertised to other services or users that can now ingest. Here in this picture, we're looking at an actual user that wants to log into their pod, and maybe they're going in there to do debugging or something else. But you get all the magic of the NAT traversal of Tailscale jumping directly into this ingress proxy, and then again, funneling the flow right down into that annotated service and the individual apps that are hosted inside of Kubernetes. We see a lot of customers having a lot of friction here, again, either having to set up jump hosts or other means to get access, and this enables them to have that one direct way. Either we're talking about the API server earlier, or now directly logging into a pod running inside of Kubernetes. Again, here this picture is talking about connecting via a laptop. We also have the idea of extending this to individual machines or services that are running in this cluster or others. Now, once we start bringing in services into the tailnet, we might also want to expose certain services to those services inside of Kubernetes. I said services a lot, y'all, excuse me. One great example of this is the idea of a database. Maybe you have an RDS that you brought onto your tailnet, and now you're ready to expose it securely down to these individual Kubernetes services. Again, this all revolves around the Tailscale operator and an external service where we spin up this egress proxy that's matched up to the service that's running on the tailnet existing. Here we're seeing on the right side of the page a database that's spun up and being made available on the tailnet via Magic DNS. And we're giving access to this external service through the egress proxy to that database, again, all securely and made available through the tailnet and not over the public internet. So very exciting here. You could have this database inside of the same cloud account, or it could be doing things when you're talking about integrating with AI and LLM APIs across clouds. Really easy to make this and make those services available to all the individual services inside that Kubernetes cluster. You also have the ability to restrict access to who can actually use this egress proxy by taking advantage of Kubernetes authentication methods already today. And finally, the big piece that we see a lot of customers doing today, and it's really hard to get right with existing solutions out in the market, is this idea of cross-cluster connectivity. And this really pairs our ingress and egress functionality into a tuple on both sides that allows certain services that are running on one side, say cluster A, to access services on cluster B and vice versa. Before we were talking about using egress to map to things like infrastructure as a service like RDS or others. Here we're actually mapping services between each other and enabling that cross communication, skipping out different load balancers and such, and really reducing your bandwidth costs. But more importantly, just simplifying the connectivity between these two things, especially when you're looking at jumping between public clouds or between maybe a hybrid private cloud and a public cloud, and making that as simple as possible for you as operators. That's really the Kubernetes story. It's one we're really only beginning. Again, really working on that human to machine where your app developers or admins need to get access into the Kubernetes cluster and looking to extend those same constructs into a machine to machine world. You're seeing a similar thing here with that TSNet that we mentioned earlier. We have this idea again of the identity being built into the network and every request coming through with a Tailscale identity that's tied to your IDP. And here we're giving you the ability to actually make programs built on top of that. And so there is this idea of the TSNet Go package, which you can import into your scripts or actual applications, allowing you to make those join onto the tailnet without having to have a sidecar or some other process running to the side. But it also gives you helpers to be able to take advantage of this identity that's coming in, allowing you to parse it and actually trust it to base your internal RBAC rules on. As you see here in the second header, an example of those headers coming through. So you don't always have to actually use TSNet. You can use your own programming languages as well if you're aware of seeing these out there. And finally, we have this ability of ACL grants. If you're not familiar, grants are a new format of writing ACLs that we think is much simpler. We also have ability there to write specific via comments and others, allowing you to restrict access inside of those applications and not just to the service itself, which is really exciting, giving you that central point to write all your controls. We're seeing customers use this, and Lauren mentioned earlier, talking about the idea of internal applications and just making sure you have identity-based access controls onto those. But we're also seeing people build their own proxies for other third-party services like Grafana, where you have your IDP or your internal Tailscale identity piping through to a service you've written, and you're able to translate that to an external ID and then make that connection through there, never exposing the third-party identifications to your internal users. So again, just trying to give you different ways to bring that into Tailscale, manage your identity, your connectivity, all in one place through your policy file. So really looking forward to the questions we're about to go into. But again, a quick run to, and some of the main ways we're seeing people connect devices, users, and services onto their Tailnet, and how they're taking advantage of the identity that's built into the Tailscale today. And with that, we'll look at the questions.
Yeah. So actually, we had one question that came up that I think we've answered, but Jordan, maybe you can add some context. David White was asking if orgs are looking to utilize best cost services across multi-cloud environments, and if so, are users finding significant latency impact? So I think we can say that our Tailscale customers are using multi-cloud for a ton of different reasons. Sometimes it's for cost, sometimes it's because they want a specialized tool or it's developer preference, engineering team preference. With some AI companies, it's just like, where can you get the GPUs? So it really depends on why they're using it. But as far as latency, the area where we see reduction in latency, what Jordan was talking about with those direct peer end-to-end connections versus the kind of standard approach on VPNs where you're maybe going through multiple gateways, the direct end connection tends to reduce the majority of latency or performance issues that can crop up when you have too many intermediary points. But I did see a question on how DERP servers might impact that. Jordan, do you want to field that?
Yeah, so for those that aren't familiar, DERP is our fallback mechanism when we can't get a direct connection. And so what Michael's mentioning here is if you do have to go through that fallback mechanism, you can see latency because you are essentially getting proxied through another server. At the high level, seeing is less hops between these services, as Lauren was mentioning, which does reduce latency. Of course, you always have to deal when you're going between major cloud providers. There are bits you're losing here, not losing or delayed, but we are able to reduce it by reducing the number of hops.
Speaking of performance, we have a bandwidth question. Is Tailscale suitable for two servers on different data centers to talk to each other with 10 or more gigabits per second of bandwidth?
The key here again is getting to those direct connections. This is not a use case we support via DERP, right? Where we don't have that direct connection and it's piping through one of our servers and route to you. But when we do get those direct connections, we are able to saturate the network.
Jordan, and just to the folks in the audience, we just had an SE, one of our solutions engineers, pop in and just give a simple yes. So yes, we're suitable for the use case that's being asked about. Yeah, and for anybody who's curious about some of the other offerings that we have that help us get to zero trust, I mentioned up top, we're going to be holding other sessions regarding some of those deep dive on other requirements, including your policy management, doing the monitoring analysis, and then adaptive policies based on the device posture or attributes that you're seeing come in. So there's absolutely a way to do that. And if you can't wait for the next webinar, you're always welcome to book time with somebody from our sales team to talk through that directly.
Going on David's question around if I have a client in the environment with excessive use, essentially a potential threat, what functionality is available today to identify and isolate them? We're not doing any automated, obviously, watching of everything that's happening for you. We are working hard to increase the observability of what's happening inside your network. Back in December, we released the idea of client metrics that allow you to connect the client up into something like Datadog or others, or some other SIEM tool, and allowing you to build custom monitoring tools here, which I do think will allow you to spot or build systems that can spot for you things that are out of normal. You do have the ability, again, we talk about the ACL file and programming access to control, the ability to pull back access very quickly from these customers or clients internally. So we do have the quick action to act, but not so much we're giving you automated tools to find these people today. I see another from earlier in the chat around our infrastructure includes multiple data centers and clouds, and we need a way to connect them to each other. We're not sure if Tailscale can handle this kind of workload. I would say it's designed for this kind of workload, and we're working more and more to make sure we can keep up with the scale that customers are demanding from us. What we see really is customers looking to flatten out their network topology across these clouds, whether you're talking about, again, public clouds like AWS and GCP, or private data centers as well, and giving one central way to connect to devices or services across those. So 100% is something we're seeing more and more usage from. We really see customers in two kind of buckets on our side. We have classic corporate VPNs that we're trying to connect and create connectivity for the business as a whole, and then lots of engineering specific use cases. And this is really, we are starting to see the multi-cloud shine.
Hugging Face is, for those of you who know, like a very large AI company, and they've been using us for zero trust posture in multi-cloud infrastructure that needs to be really high performant. So those connectivity points are being supported by Tailscale directly. Has anybody here? I was really excited that we got to share about TSNet and what you can and how you can use it to create some identity aware apps. Is anybody here using TSNet?
It's not surprising if not. To be honest, I begged Lauren to include it because it's our pet project for the years. We really try to push that message of how you get more value from what we're offering here. There's the idea of, again, your VPN replacement, but what else can your network do for you? And I really do think is for engineers, whether you're talking about just like reducing a bunch of the RBAC headaches you have to build, is a nice little bonus, but also the idea of just having one way to build these applications inside of a business is really intriguing to me.